Good day, Sci folks! Teacher MJ is here again to be with you in exploring, discovering, and enjoying life through Science 8. How are you? I hope you're doing fine. It is now time to prepare your modules, paper, pens, and everything you need for our learning session. All set? Great! Now we are ready to dive into the world of science. This is DepEd TV. In the last episode, we started talking about the scientists behind the concept of force. Also, we talked about the first law of motion, which is the law of inertia. I hope you still remember all of those. Last time, we discussed the law of inertia, which tells us that an object at rest will remain at rest and an object in motion will continue to move at constant velocity unless acted upon by a net force. This time, let's proceed to the next law of motion, the law of acceleration. What is acceleration? We can recall from our previous episodes that acceleration is the time rate of change of the velocity of an object. The law of acceleration states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to the object's mass. The direction of the acceleration is in the direction of the net force acting on the object. Take a look at this example. A person is pushing a pile of fish boxes with a mass of 50 kilograms. As you can see, the acceleration of the pile when pushed is not that fast. But if 3 people will push it, the pile will have greater acceleration. Why? That's because the net force acting on the pile of fish boxes increases, which also increases its acceleration. The greater the magnitude of force applied, the faster the pile accelerates. What if the same 3 people push a boat with the same amount of force exerted in pushing the pile? Do you think it will accelerate as fast as the pile of fish boxes? Let's see. You observe that the boat did not move as fast as the pile with the same group of people exerting force on it. But when 3 more people exert additional force to the force of the first 3 people, the boat accelerates faster. This is because the acceleration of the boat is inversely proportional to its mass. The greater the mass, the harder it is to accelerate. Thus, we need to add more force if we want it to accelerate faster. The law of acceleration is expressed through this equation. The symbol sigma stands for the algebraic sum, thus, sigma F stands for the net force acting on an object. On the other hand, M stands for the mass of the object and A for its acceleration. The arrow above the letters F and A indicates that both have magnitude and direction. For you to better understand this, you have to be familiar with the correct units for mass, acceleration, and force, which vary from one system to another. Take a look at this table. For the meter kilogram second or MKS system, we use kilogram for the mass, meter per second squared for the acceleration, and Newton for the force with a dimension in the MKS system as kilogram meter per second squared. For the centimeter gram second or CGS system, gram for the mass, centimeter per second squared for the acceleration, and dyne for the force. Lastly, For the foot-pound second or FPS system, slug is used for the mass, foot per second squared for the acceleration, and pound for the force. Did you get it? Now take a look at these sample problems. Take note of the important details for you to be able to do it independently when I ask you to do it. For the first sample problem, let's say a 1,000 kilogram truck is traveling at an acceleration of 4.5 meters per second squared east. Find the net force needed to accelerate the truck. The first thing we must do is to take note of the given information in the problem. We have acceleration which is equal to 4.5 meters per second squared east. We also have mass which is 1,000 kilograms. Now that we have taken down the given, let's write our solution. We write net force equals the mass multiplied by the acceleration. Our mass is 1,000 kilograms. Our acceleration is 4.5 meters per second squared. We multiply these and the force needed to make the truck move is 4,500 newtons east. For our next example, let's say a boy rolls a 200-gram baseball horizontally on the floor with a net force of 2 newtons to the right. What is the acceleration of the baseball? This time, it's not the force we have to look for. We are going to solve for the acceleration. So look closely for you to know how to do it. For the given, we have mass which is 200 grams and the force which is 2 newtons to the right. Notice that the units of the given are not of the same system. The mass is in the CGS system and the force is in the MKS system. So what should we do in this case? We just have to convert the unit of the mass into the MKS unit. From gram, we convert it into kilogram. As we know, 1 kilogram is equal to 1,000 grams. So 200 grams becomes 0.2 kilogram. After converting, let's solve for the acceleration. We first write the formula. Net force is equal to mass multiplied by acceleration. Force is given at 2 newtons. Then the mass at 0.2 kilogram. And since we are looking for the acceleration, we'll leave it as A. Next, we have to divide both sides of the equation with mass. Thus, the equation becomes A is equal to F over m, or 2 kilograms meter per second squared, divided by 0.2 kilogram. We also have to convert the unit of the force, which is Newton, to its equivalent, which is kilogram meter per second squared. That will allow us to meet similar units in the process. After that, we do division and come up with 10 meters per second squared. Thus, the acceleration of the baseball is 10 meters per second squared to the right. Can you follow? I hope you can. Let's keep moving. What if a problem asks you to find mass? How are we gonna do it? Let's have this problem. Let's say a box is pushed with an applied force of 20 newtons parallel to the floor. It accelerated at 1.50 meters per second squared to the right. A parallel applied force of 10 newtons on the opposite side is slowed down the motion of the box. Neglecting friction, What is the mass of the box? For the given, we have acceleration, which is 1.50 meter per second squared to the right. We have two forces, force A, 20 newtons, and force B, 10 newtons. For you to be able to fully understand the problem, I have here a picture showing the box, the forces, the acceleration, and the direction of the motion. Before we solve it, we have to do some initial computations since we have two forces given. What do you think should we do? Right! By finding the net force, we have to add the forces. That would be net force is equal to positive 20 newtons plus negative 10 newtons. We get positive 10 newtons. Just in case you forgot, always remember that we give positive sign for forces directed to the right, and we give negative sign for those directed to the left. The negative sign does not mean that the force is less than 0. It only indicates the direction of the force. Now we are ready. Let's write the equation. Net force is equal to mass multiplied by acceleration. Then we plot the given in the equation. Positive 10 newtons for the net force. We'll leave mass since it is the one we have to look for. Then acceleration is 1.50 meters per second squared. We again have to express Newton into its equivalent, and that makes it 10 kilograms meter per second squared. Then we divide both sides of the equation with the acceleration. So we have positive 10 kilograms meter per second squared divided by 1.50 meters per second squared. Then we cancel or omit similar units. We divide 10 by 1.50, we get 6.67 kilograms. Thus, the mass is 6.67 kilograms. All clear? Great! Let's test your understanding. Prepare your pen and paper and try solving these problems. You'll have a minute to solve. Ready? Okay, let's do this! A car with a mass of 700 kilograms suddenly stopped on the road. The driver asked the bystanders to help him push the car to the nearest auto shop, which is located few meters east of their current location. The people pushed it at 3,000 newtons. What is the acceleration of the car? What is your answer? If your answer is 4.29 meters per second squared, then you did a great job. That is correct. Now for our next problem. A bowling ball with a mass of 7.3 kilograms was rolled by a boy with an acceleration of 1.5 meter per second squared to the right. Find the net force needed to accelerate the bowling ball. Do you think you got it right? What is your answer? The correct answer is 10.95 newtons. You guys are really doing great. Keep up as we continue our discussion. Before going to the third law of motion, let's have a glance with the force of gravity, which affects the weight of an object. This is related to the second law of motion. In one of Galileo's experiments, objects dropped near the surface of the Earth would fall with the same acceleration if air resistance is neglected. This acceleration due to gravity is denoted by g with an approximate value of 9.8 meters per second squared, or 980 centimeters per second squared, or 32 feet per second squared. The force that causes acceleration is called the force of gravity or gravitational force. The force acts toward the center of the Earth. The gravitational force on an object can be expressed as F of g is equal to m times g, where F of g is for gravitational force, m is for mass, and g for acceleration due to gravity. The direction of this force is always directed towards the center of the Earth. The magnitude of the force of gravity on an object, mg, is called the object's weight, symbolized by the letter W. When a person's mass is 40 kilograms, the computed weight of that person on Earth is 392 newtons, which is obtained by multiplying the mass to the MKS approximate value of the acceleration due to gravity, which is 9.8 meters per second squared. His weight differs when he is on other planets and satellites like the Moon. Now it's time to proceed with the third law of motion, known as the law of interaction. To better understand this, here is an example. As I push the wall, it's not only me exerting a force. The wall is also exerting a force back on me, as the law of interaction tells us that a force exerted on any object is always exerted back by an equal magnitude of force, but in opposite direction. In this law, forces come in pairs. These are called action and reaction forces, and they do not act on the same body. In determining the action and reaction forces, be able to identify first the action that requires force, and then identify the reaction force that counteracts the action force. In this video, I am the one exerting the action force, and the wall exerts a reaction force that counteracts the force I applied when I pushed it. There you have it, Sci folks. Newton's 3 laws of motion. I hope you learned something from our discussion on this. To test what you have learned, I have here questions for you to answer. Write your answers on your paper, and count your scores when we're done. I hope that you will get a perfect score. Are you ready? All right, let's do this. Blank is the tendency of an object to resist any change in its initial state. If it is initially at rest, it tends to remain at blank. On the other hand, if it is initially moving at constant velocity, it tends to continue moving unless acted upon by a blank. Inertia depends on the object's blank. Newton's blank, also known as the blank, states that an object at rest remains at rest and an object in motion will continue to move in a straight path with constant velocity unless acted upon by a net force. Newton's blank, also known as the blank, states that acceleration of an object is directly proportional to the net force causing it and inversely proportional to its mass. In symbol, sigma F is equal to m times a. Newton's blank, also known as the blank, states that for every action, there is an equal and opposite reaction. What is the definition of weight? A. The size of an object. B. The time it takes to get on a ride. C. The amount of matter in an object. Or D. The magnitude of the force of gravity on an object. Which law states that forces act with equal magnitude and in opposite direction? A. Law of inertia. B. Law of interaction. C. Law of acceleration. Or D. Law of gravitational force. For every blank, there is an equal and opposite blank. A. Action, action. B. Reaction, action. C. Action, reaction. Or D. Reaction, reaction. What Newton's law of motion requires the use of seatbelt in cars? A. Law of inertia. B. Law of interaction. C. Law of acceleration. Or D. Law of universal gravitation. A guava with a mass of 0.200 kg has a weight of A. 0.200 Newton. B. 1.96 newtons. C. 4.50 newtons. Or D. 10.0 newtons. Congratulations, Sci folks! We have successfully finished our discussion on Newton's laws of motion. Did you get a high score in our test? Great! Indeed, you are enjoying science. With that being said, I'll see you again in our next episode where we will explore, discover, and enjoy life through Science 8. This is your teacher MJ, and this is DepEd TV.